In this section, we're going to take a look at different ways of representing data or information, particularly with algebra. A lot of times we'll look at patterns, generally given by tables. We'll look at equations, and we'll look at graphs. So there's multiple ways of representing any piece of information. So we're going to take this example and show kind of how this works. So I can look at the blocks and say, okay, if this is figure 1, this is figure 2, this is figure 3, this is figure 4. What is the representation between the number in the sequence or series and the number of blocks? So for example, this could be n, and then this is the number of blocks underneath each. So my number in the sequence, if I was to write a graph, might be 1, 2, 3, 4. Okay. The number of blocks, we'll call it B, is given by 1, 2, 3, 4 as well. Okay. So if I was looking for the nth term, I could also say it's going to be n as well. Okay, that my n and b are the same. So what I can do then is create a graph. Say, okay, if I was doing a graph where my n values might be here, because they're the independent variable, or sorry, and b is the dependent variable. The number of blocks depends on what number figure it is, what figure number it is. I could say then that if I were to plot this out, if figure 1, I've got 1 block, figure 2 has 2 blocks, figure 3 has 3 blocks, figure 4 has 4 blocks. So if I wanted to predict sort of the flow of the blocks, I could almost create like a dashed line just to kind of show where it would go. Okay, just as a way of showing what the pattern would be. Then I can create sort of a an equation where my x value might be this, my y value would be this. My x would equal my y. So this would be my equation. So if I knew x equaled 30, my y would also equal 30 as well. Let's follow this with another example. So here, taking the same idea of figure 1, 2, 3, and 4, okay, I have 2 blocks, I have 4 blocks, 6 blocks, 8 blocks. So if I were to graph or put this in a table, n, we can say would be the blue, okay, what figure? 1, 2, 3, and 4. The number of blocks would be given by 2, 4, 6, and 8. So if I were to graph this, it would be kind of very similar in sense 1, 2, 3, 4. Okay. But then for blocks, I might do 1, 2, 3, 4, 5, 6, 7, 8. Okay. 4 would be 8, 3 would be 6, 2 would be 4, 1 would be 2. So it would be kind of similar in the sense of ending up with a straight dotted line for this particular pattern. Okay. When it comes to writing the equation, I can notice that if I speak in terms of x and y, although I could continue with n and b, but x and y usually make a lot more sense when I'm dealing with the graphs. Okay. Making sure that I also label these axes. I could say that my y value is given by taking 2 and multiplying it by the x value, or my b value is equal to 2 times n. So most of the stuff we've worked with before, we've worked with tables, we've worked with patterns, we've worked with graphs, we've worked with equations, but it's important to see any sort of data, any piece of information we're working on, how each of these relate and how you're able to represent it in different ways depending on the situation and depending what might be the easiest to be able to work with. Okay, and when we're trying to find extensive data, we could continue the pattern down in the table to get to an answer. We can look at a graph, and if you graph it a little bit more accurately than this using graph paper, sometimes you can get to an answer. or you can also work with the equation itself as well and so get an answer quickly that way.